In this concept, we're going to talk about solving inequalities with absolute value. Now consider the following inequality. The absolute value of x is less than 3. Now what does this mean? When we have the absolute value sign in an inequality, what we do is that we take both the positive and the negative of the number that's on the other side of the inequality. Right? So what this is telling us is that the distance from 0 to x is less than 3 units. Okay? Whether x is less than 3 or x is greater than negative 3, okay, so whatever the value of in the inequality, right, whatever the value of x is, the distance between 0 and that value is less than 3 units of distance. So the way we write it mathematically is that we take this and we convert it to two inequalities, right? One says x is less than 3, and the other says x is greater than negative 3. Okay, let's look at the different manifestations of this type of inequality. So the first case of inequalities that have absolute value signs involve the less than sign. So the less than or the less than and equal sign. Okay, and solving inequalities with less than or equal, we find the intersection of the two instances, okay, or cases of the inequality. So let's look at what this means. So if we have absolute value of x is less than n, excuse me, we have case 1 or instance 1, which is x is less than n, and we have case 2 or instance 2, x is greater than negative n. Okay, so x less than positive n and x greater than negative n. You have to write both of them, and you want to find the intersection of both of them, which is essentially the and operand. Okay, so remember the and operand on a number line. It tells you to take the intersection of two expressions. Okay, and this is exactly what we would be doing in this case, taking the and operand of both of these expressions. Okay, and again, this is only if we have the less than or the less than or equal inequality signs. Let's look at an example. So solve x plus 3 absolute value, the absolute value of x plus 3 is less than 4. So we write out our two cases, right? Case 1 we have x plus 3 is less than 4. In case 2 we have x plus 3 is greater than minus 4. Okay? Then just solve each case for x. Isolate the x, right? So you have here we can subtract negative 3 from both sides, so we'll have x less than 4 minus 3, which is x is less than 1. Here again we just we just solve for the x, so we can subtract 3 from both sides. So we have x is greater than minus 4 minus 3, meaning x is greater than 7. So since we need to take the intersection of both expressions, we have x is less than 1, so we go to 1 and we draw an open circle, again because 1 itself is not included, but everything less than 1 is included, and we go this way, right? And then we go to minus 7, we draw an open circle. Again, minus 7 is not included, but everything greater than minus 7 is included. And we go this way, right? But then the actual result of this expression is the intersection of both, right? Which is whatever is between these two circles. Okay, as you can see on the black solid line. Okay, let's look at the second case of inequalities that have absolute value signs. So if an inequality has an absolute value expression and it also has a greater than or equal sign, then in this case we want the union of the two cases as opposed to the intersection of the two cases. Okay, we want the union of both cases. So let's look at here's what we would have. So if we had absolute value of x is greater than n, right, some number, we break it down to the two instances, right? X is greater than n and x is less than negative n. Okay, just like we had before. So when we take the negative case, we have to flip the inequality sign from what it was in the beginning. Okay, so if it were greater than, we make it a less than. If it were a less than, we make it a greater than, etc. And then we take essentially the or operand for union. Okay, so union is the or operand. Intersection is the and operand. Okay, let's look at an example. So solve the the absolute value of 3x plus 8 is greater than or equal to 5. And then graph the solution. So again, we break it down to our two cases or instances. So 3x minus 12 absolute value is greater than or equal to 3. Yeah, this seems like it's a typo. So this should be 3x minus 12, right? 3x minus 12 greater than or equal to 3. Okay? So we break it down to the two cases again. So we have 3x minus 12 is greater than or equal to 3. And we have 3x minus 12 is less than or equal to negative 3. Okay? So again, one expression or one instance involves the expression as is, but just without the absolute value sign. The other expression or instance, okay, involves removing the absolute value sign, flipping the inequality sign, right, and then adding the negative of this expression on this side. Okay? And then here we just solve each expression for x. So here we just, followed typical inequality solving strategies to get to x is greater than or equal to 5. And here we just followed typical strategies to solve the inequality. And we got to x is less than or equal to 3. So now we have both of these expressions, and we need to take the or operand between them and graph them on the number line. So let's look at this. So x is greater than or equal to 5, so we have a solid circle on 5 because we include 5, and then everything that's greater than 5. Okay? And then we go to 3, solid circle because we include 3, and everything less than 3. Okay? So for the or operand, both of these are part of the solution. Okay, so the solution involves both of these arrows, both of these regions on the number line. Okay, so the solution set is x such that x is less than or equal to 3 or x is greater than or equal to 5. Okay, so here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, so let's look at what we have here. So we have absolute value of 2x minus 9 is less than negative 1. So remember, since we have a less than sign, right, we need to use the and operand, or basically take the intersection of both instances of the inequality. Okay? Oops, intersection, right? So let's look at what we have. So we have the first expression, or the first instance, is 2x minus 9 is less than negative 1, right? And we have 2x minus 9 is greater than plus 1, okay? So if we solve, we have, so x is less than minus 1 plus 9 over 2. Again, I just combined the steps to save some space. And then here we have x is greater than plus 1 plus 9. We brought the 9 to the other side, divided by 2, right? So we have x is less than 4, and x is greater than 5, right? So let's draw this on the number line. Actually, let's draw it a little higher. Okay, so 4, 5, 0. Okay, so actually, four, 5, 0. Okay. So x is greater than 5, so open circle at 5. And x is less than 4, open circle at 4. So x is greater than 5 looks like this, so it's an arrow that goes this way, right? And then x is less than 4 is an arrow that goes all the way this way, right? Whatever is less than 4. But to take the and operand, essentially we need the intersection. But there is no intersection to both regions, right? They just don't intersect anywhere. So this inequality actually has no solutions. Okay? Because there's no region, there's no solution that fulfills the and operand for these two expressions. Okay? So the solution is that there is no solution. Moving on to the next example. 5x plus 7, absolute value of which is less than or equal to 8. Again, since we have a less than or equal to sign, we write out our two expressions. 5x plus 7 is less than or equal to 8. And, right, so we need the and operand because we have less than or equal to. 5x plus 7 is greater than or equal to minus 8. And again, I'm just going to combine steps now. So x is less than or equal to 8 minus 7 over 5, which means x is less than or equal to 1/5. And here I'm going to combine steps again. X is greater than or equal to minus 8 minus 7 over 5, which gives x is greater than or equal to minus 3. Okay, so graphing this on the number line, we have 0, 1/5, and then minus 3 is somewhere here, right? So x is greater than or equal to minus 3, so it is whatever it goes this way, and then x is less than or equal to 1/5 is whatever goes this way. So my solution is the intersection of both regions. Okay, so it is essentially the region between minus 3 and plus 1/5. Okay, this is my solution. Moving on to the last example, we have x plus 5 absolute value of which is greater than 8. So we write our two expressions, but with the OR operand, okay, which is the union of both of them on the number line. And then x plus 5 is less than minus 8. Okay, so greater than 8, less than minus 8. Okay. Solving for x, we have x is greater than 3, right? 8 minus 5. Or x is less than minus 13. Graphing this on the number line, we have 0 somewhere here, we have 3 here, and we have minus 13 here. Okay, so open circle at 3, and x is whatever is greater than 3. Okay, and then open circle at minus 13, and x is whatever is less than minus 13. And this is my answer. Okay, it is both of these regions. Okay, this is my solution. I hope this was clear. This is it for this concept. See you in the next video.